So the last time we started to explore the logic of the Malthusian economy. And remember I said that we just need three assumptions, it seems, to describe the world before 1800. The first idea is that the birth rate is going to increase as income per person increases. Second simple idea is that the death rate will decrease as income per person increases. And then this third important idea is that incomes will decline as population increases. And the reason for that is that these societies depend on land for production. There's a fixed supply of land per person. As population goes up, you have to produce more output per acre in order to maintain living standards. And it's possible always to increase output per acre by more intensive cultivation methods. And we see extreme intensity in places like the Yangtze Delta in China. But it's not possible to increase output in line with population once you have this fixed factor, land. And so as population goes up, total output increases, but output per person actually declines. Okay? Now, what we can do is we can actually show, again, on one picture, all of the essence of this model. Okay? And so this picture, though, has two panels. One has to be right on top of the other. On the top panel here, we have on the horizontal axis income per person. And then on the vertical axis, we have both the birth rate in the society and the death rate in the society. Okay? And then on the bottom panel, again, we have income here, so that it'll always show income in the horizontal direction. But now we have population on the vertical axis. And so what do these three assumptions look like once we graph them? Well, the first one simply says that there will be a birth rate schedule, an upward sloping association between birth rates and population, which will look like this. The second assumption simply has this implication here. There'll be a death rate schedule, a declining frequency of deaths per head of the population, again, as incomes increase. Okay? And then this third assumption, which is graphed down here, says that the relationship between population and income will look like this. Okay? It'll have this inverted shape. At high levels of population, income is going to be low, and at low levels of population, income is going to be high. Okay? And this is graphed. The normal way we do graphing is to have the independent variable on the horizontal axis and then the dependent variable on the vertical axis. But to make this all fit together, we do it the other way around, right? This is what's determining this, okay? But that's fine. It's just a different way of graphing the thing, right? And so the important thing to understand in this model is that the fundamental variable at all time is population here. That's what's driving the rest of the system, right? And population is going to drive income, and then income is going to drive what are birth rates and what are death rates. Okay? And so those are the three assumptions. And as I say, these are very simple assumptions about how pre-industrial societies would have to operate. And then to see what's going to happen, all we need to do is let's just start with some arbitrary population. Okay? And so let's start with some low level of population, N0 here. What will happen in this society? Well, at that level of population, people are going to be living well. There's lots of land per person, and there's lots of output per person in this society. And because people are living well, what's going to happen is that the death rate in the society is going to be relatively low. There's lots of clothing, there's lots of housing space, there's lots of nutrition for people. And the birth rate is going to be relatively high. Okay? Women are well nourished, they're healthy, there's plenty of food to feed families, And so we'll have both a high birth rate and a low death rate. But if the birth rate exceeds the death rate in this society, at any point where the birth rate exceeds the death rate, population can't be stable. It's got to be growing. And so in the next generation here, what's going to happen is we're going to start moving along this curve here. We're moving upwards along this curve as long as the birth rate exceeds the death rate. And in fact, we have to keep on moving up along this curve until we get to this income level Y star. And once we get to that income level Y star, population will stabilize. Now we'll be in an equilibrium. We're in a situation where births equal deaths at this income Y star. And similarly, down here, population stabilizes. It stops moving along this curve. And so what this then immediately implies is that in any such society, if we start with a very small population, we won't stay at that situation. We've got to move to this point where the birth rate equals the death rate. And remember, that's what I said is the dominant feature of all societies in the world before 1800, is that birth rates have to end up being very close to death rates. Okay? And you see here that this is why that has to be the case. It's because with this land constraint, you're always going to move to that point where birth rates finally come to equal death rates. And that's why there's a special name given to this income Y star. And that income is the subsistence income of the society. And what we mean by subsistence in discussing a Malthusian model is not the income at which people just manage to avoid starving to death each day. More complicatedly, it means the income at which the human population is just able to reproduce itself, in which one generation is replaced by another generation of an equivalent size. That's what subsistence income is. And what we're going to see is that that subsistence income can exceed the starvation level of income in some pre-industrial societies by a factor of 10 or 20. In the right conditions, these Malthusian economies can actually be very wealthy ones and can have living conditions that are high even by the standards of the modern world. Right? So the first important thing then to understand about this model is that it has a dynamic. It's headed towards this subsistence income. But the important thing is that that subsistence income is not a starvation income. Right? And also, we're going to see that it can vary across different societies depending on what the location of these birth rate and death rate schedules is. Okay? Just to complete this explanation, let's also think about, well, what if the society ended up with a very high population here, N1? What would actually happen in this case? What would happen now is that you would start off with a very low level of income here. At this very low level of income, what's going to happen is that death rates are going to be very high and birth rates are going to be very low. Okay? If deaths exceed births, then the population by definition has to decline. So as we go from one generation to the next, we're moving to a smaller population. And we start, in this case, moving down this curve. And as long as we're to the left of this subsistence income level, it's got to be the case that death rates exceed birth rates. And so it's going to be the case then that we keep on moving until we get back to this equilibrium point. So with this simple specification, you immediately have this conclusion that there's only going to be one long-run income level for each of these societies, Y star. And the society will automatically, in a matter of generations at least, adjust to that income level. Okay? Now, I've done everything here in terms of income because I'm going to also talk about hunter-gatherer societies where there is no such a thing as wages, right? Initially, the classical economists who talked about this talked about it in terms of wages. But you can actually redraw this diagram and just put wages here instead of income, right? Now, wages are not the same as national income because national income includes rents to capital owners and landowners. But it turns out that this assumption would still be correct if we put wages in there. This assumption would still be correct if we put wages. And it's also the case that wages will decline as population goes up. Okay? And so you can actually redraw this diagram in terms of wages. And so then you would also have the conclusion that there will be a subsistence wage level for each society. And it was that conclusion which led to one of the famous laws of classical economics, which was the iron law of wages. And the iron law of wages simply said, in the long run, all societies are headed to a subsistence wage level. Right? It's possible to escape temporarily with some economic growth, but in the long run, you're going to be bound by this subsistence wage level, and it's impossible to improve the condition of the workers in the long run. Their condition is actually governed by this iron law of wages. And that's one of the reasons why classical economics was regarded as very kind of conservative in many ways politically, and very pessimistic outlook in terms of the possibilities for societies. So this is the simple model then, the Malthusian model. Let's then think about what are the implications of this model. Okay, so the first one is that there's this subsistence income or wage that's going to govern each society. A second thing that we should be clear on is that you don't need to have an increase of birth rates with wages or income for this model to still hold. This curve could be flat, and you'd still be in exactly the same world, right? It can even be downward sloping, and you could still be in the same world. All that has to happen, actually, is that the fertility change with response to income is less than the mortality change, right? And so you actually, you need this, that mortality is going to decline, it's going to increase, decline with income. But you could actually have just no response of fertility to income, and the model would actually still work in that case, okay? And so it's, the model I gave you is actually more restrictive than a general Malthusian model for the pre-industrial world. A second thing we can actually learn from this model, or in this world, is that when we reach this equilibrium, this point where birth rates equal death rates, it turns out that there's a very convenient condition which holds, which is that the birth rate will be the inverse of life expectancy at birth. Okay? So in every society, when people are born, there's an average length that people are going to live to, and that is your life expectancy at birth. Okay? Now, for someone like modern America, it'd be between 75 and 80 years. There's actually, we'll see as we go through this, there's a life expectancy at every year, or at every age, right? There's a life expectancy at age 50, which is how many more remaining years you're going to live. There's a life expectancy at age 90, which is how many more remaining years you're going to live. And it doesn't decline one for one. Every year you live, you actually don't lose a year of life expectancy. It's a nice feature. It doesn't apply so much to you, but when someone get to my age, you realize that every day you survive, you didn't spend an entire day, right? You actually, because otherwise, since life expectancy at birth is 75 or 80, once you got to age 90, you'd have to say everyone's life expectancy is 0. But in fact, it's not 0. Even at age 90, you have a life expectancy of something like 6 or 7 years still, okay? And so I have to say, it's something that you can think about as you get older, which is that any day, I didn't just waste a day. I wasted less than a day, okay? And actually, in the pre-industrial world, your absolute life expectancy did not maximize until you were something like 12 years old. Life expectancy at age 12 was actually greater than life expectancy at birth, because childhood was so dangerous that if you'd survived it and proved that now you're one of the tough ones, you could actually then have significant life expectancy at that later age. Okay? And in fact, there's a nice, since it's Friday, let me tell an anecdote, which is the reason people first began to focus on life expectancies was that in the 18th century, governments, in order to raise money, started offering annuities, which were payments that depended on the length of life of the person, right? It was a payment per year that lasted as long as the life of the person. And so then they had to calculate, well, how much should we offer in terms of what kind of rate of return should we offer on these annuities? And so people then started calculating these life expectancies. And it turns out that the French government, in the years before the revolution in 1789, offered life annuities where you could either name yourself or you could name anyone else you wanted in terms of how long that annuity would run. So you could either say the name on the life annuity is myself, it terminates when I die, or I could name someone else. The only trouble was you had to prove each year that the person named on the annuity was still alive, which was cumbersome. And so a lot of people then in France actually named the king or the queen, because then it would be obvious who's alive and who's not alive. That meant in the French Revolution, when the revolutionaries executed the king and the queen, they terminated this huge stream of payments from the French state and actually did a lot for public finance in this period, right? So that was how the annuity worked in France. Now, it turns out that Geneva, which is right next to France, had a very sophisticated set of bankers. And so what they immediately thought is, well, how can we make money out of this, right? The normal return on capital in this period would be 5%. These annuities were offering 10%. How can we, but the trouble is that they're dependent on someone's life, so they're not very attractive investments. But what they then said was, we need to find a pool of people that will actually buy annuities in their name, pull them together, and then sell them to the public. And they then figured out, well, who should we get who has the longest life expectancy? And they figured out it was 12-year-old girls in Geneva. So they identified 12 girls who seemed to have very good life prospects, bought millions of dollars worth of these annuities based on these people, proved they were alive every year by parading them before the French ambassador, right? And then the papers would report in on how this common investment pool was doing. And it turns out that I think only one of those girls died before something like 20 or 30 years, right? And so it was a very sophisticated operation which was going to cost the French state a huge amount of money. After the revolution, the French state just said, we're not paying, right? You cheated. It's interesting how quickly people actually caught on to these financial possibilities. These were obviously smarter bankers than a lot of the ones who were working for AIG recently. And so you have this feature then of the pre-industrial world that one of the conditions of life, when we're looking at living conditions, we not just care about material consumption, we also care about, well, what's life expectancy? And it turns out that that emerges from this diagram as well, because it's just going to depend on where those two things are intersecting, right? Where birth rates equal death rates. That will determine life expectancy in the society. And since it turns out in most pre-industrial societies, birth rates were between 30 and 50 per 1,000 people. That is, if you had a population of 1,000, you'd get between 30 and 50 births each year. In modern societies, that number would be much closer to 10 per 1,000 people, right? Because we have much lower birth rates. But in pre-industrial world, because you had something like 30 to 50 births per 1,000, if you invert that number, right? So if you invert 50 over 1,000, the answer is that that implies a life expectancy of between 20 and 33 at birth. And so life expectancy was relatively low in the pre-industrial world, and the only way to increase that life expectancy is actually to somehow reduce the birth rates in these societies, okay? But in these stable populations, we can actually figure out that life expectancy at birth for many of these societies might have been as low as 20 at birth, okay? Now, as I say, mostly these children died very young. In a society with life expectancy at 20 at birth, there are many 20-year-olds who would have a life expectancy of a further 20 or 30 years, right? And so adults still had decent life expectancy, but on average in this society, life expectancy is going to be very low, okay? And so a second thing that emerges from this model then is that life expectancies will actually be relatively low in most pre-industrial societies. In terms, by the way, of the modern world, now birth rates range from something like 8 per thousand. In some sub-Saharan economies, birth rates are in the order of 50 or 60 per thousand, right? And so there are still some societies in modern Africa, actually, who have birth rates which are higher than the average birth rate in the pre-industrial world, right? So we've actually moved out of that range that we would typically observe in pre-industrial societies. So that's the second thing we learn here. What else do we learn from this model? Well, the next thing that we learn, and this is actually a very powerful and kind of stunning point, is that in determining living standards in this world, this curve here is irrelevant. Okay? This point here is determined only by birth rates and death rates. It doesn't depend on this relationship between population and income. What determines the location of that curve is actually two things: the natural resource base of the society, but also the technology of the society. So technology is actually embodied in terms of where that curve lies. With a better technology, the curve lies further out. Okay? With better weather, the curve would move further out, right? And so there are lots of things that will shift this curve, right? But that is the underlying technology of the society. That's how it enters into this model. But the crucial and kind of surprising thing here is that living standards in the society are not directly influenced by the technology. They're also not directly influenced by capital accumulation, by the interest rate in the society, by anything else that will all end up shifting this curve here. Okay? We'll also see that they'll be independent of taxation policies in the society, because it turns out that, again, is something that would just shift where that curve was located, right? And so all of the kind of usual things we think about in economics turn out to have nothing to say in terms of the determination of living standards. Living standards depend only on what kills people and what causes people to be born. Okay? And as I say, that is a kind of a stunning thing that emerges very quickly from this model. And it has one very powerful and immediate implication, which is we observe in the pre-industrial world a huge range of technological sophistication. We can go back to 100,000 BC, and it turns out that not only were people in 100,000 BC hunter-gatherers, they're also very poor hunter-gatherers. There's really not a lot that they can actually hunt. They tend to actually hunt only very slow-moving animals. You can actually observe in the archaeological record how people learn gradually to hunt bigger and bigger and more ferocious things, right? But they're still at the stage of kind of mollusk hunting back in 100,000 BC. And so you get this society with incredibly primitive technology. And then if you go to somewhere like England in 1800, it's a society of quite considerable sophistication, right? How many of you have been to London? Fair number. Well, when you go to London, one of the things you can, for instance, do is go to visit the house of Dr. Johnson, who's the guy who composed the first major dictionary in English in the early 18th century. And so they actually have a museum of the house where he did all of this work. And what's amazing about that house is, he was just a middle-class hack writer, is it's a house that if it was on the market in Davis would sell for probably $1 million, right? It's actually quite handsomely constructed. It has a lot of kind of interesting, attractive features. And so somewhere like London by 1800 is a society with, coffee shops. They had Starbucks before we had Starbucks. They have tea rooms. They have taverns. They have newspapers. They have opera. They have concerts. This is a highly sophisticated society. But the interesting implication of this model is that across that entire range of societies, there's nothing in the model says that people would actually get better off, right? That you can be as technologically sophisticated as you like, but as long as you're still in this Malthusian world, and we'll talk in a second about what will keep you still in that Malthusian world, it makes no difference in terms of the expected living standards from the society. And that's why I said that, the first kind of thing we're going to look at empirically in the book is this interesting implication that there should have been no systematic improvement in human living conditions for the first 100,000 years of people's existence, right? Because it turns out that technology itself will not do it for you in terms of improving living conditions, okay? What is the effect of technology? Okay, to consider that, let me just clean this up slightly. And let's say, what would the effect of technological advance be? Okay, now, as I say, what does a technological advance look like in this world? What it looks like is a shift of this curve outwards. Now, here we had the old equilibrium. Let's think about what some simple technological advances could be. In England, in 1300, grain yields were astonishingly low. For every seed of wheat they put in the ground, they got 3 back in the form of yield, and then one of them had to go in the ground again as seed. And so basically you had a yield of something like 3 to 1 in terms of grain yields. Okay? By the 19th century, they were up to a yield of about 10 to 1. Okay? And so you have an agricultural system here which has these very low yields. There are simple technological things they learned that can actually substantially increase those yields. When that would happen, at a given population, incomes would rise considerably because now there's much more food available per person, right? If you just learned how to improve those yields, right? So technological advance can consist of things like improvements in agriculture, better systems of animal husbandry. There's learning to use coal as a source of fuel, again, would shift this curve out. Anything that improves the output of the society from a given set of inputs will simply shift that curve out. Another thing that could affect the curve is also weather, right? So for example, the climate has varied even within recorded history. There's a time in the Middle Ages in England when the manors are actually growing grapes and making wine, right? That disappeared within about 100 years, and we think that that must be associated with climate shifts. All of these things will influence where this curve lies. Now, if that's a one-time and a sudden change, what would actually happen then is that incomes would jump upwards. And now we'd be living at this much higher level of income. But at that level of income, birth rates once more exceed death rates. We're caught in the old Malthusian vice, right? Birth rates exceed death rates. And so what will happen is population starts increasing, but it's increasing along this curve here now. And so what is now happening is that that population has to keep on increasing as long as birth rates exceed death rates. And so we end up, instead of going from here to here, in the long run, we move vertically. Okay? And so what's the result after this population, after this technological advance is fully absorbed? The result is the birth rate's the same, the death rate's the same, the subsistence income of the society is the same. And all that has happened is we've increased the stock of population. And so that is what we believe was the main effect of technology all the way from 100,000 BC till 1800. There was actually, over that time, a slow but kind of very steady advance in human technology. All the way through that period, right? Now, there are periods of stasis. We can observe one in England where we get a period of something like 300 or 400 years with no evidence of any technological advance. But over this long period, over century after century, there's a steady upwards drift. And all of that drift, we think, simply went into increasing the stock of human population. And so we started out, with maybe 100,000 BC, back sometime way in the past. By 1750, there are about 750 million people in the world. And that is the result, as I say, of a considerable amount of technological advance. What I'll actually show you as we get into the course here is it's possible to take those numbers and actually calculate the rate of technological advance just from the population in this Malthusian world. It's actually possible to impute backwards and figure out the level of technology at any time simply by figuring out what's the relationship between the population and how good the technology of the society is, right? And so we can actually measure these rates of change. And that's why we know that these rates are dramatically lower than the modern world, right? That there's something fundamentally different about all pre-industrial societies in that they have this very slow rate of technological advance, okay? And then the next thing we learn here is, well, why can't we escape this Malthusian world? And the answer is, it's because that curve is moving out so slowly that population always has time to adjust. If that curve would actually shoot out very rapidly and keep moving out rapidly, then even though birth rates exceeded death rates, you wouldn't be forced back to the equilibrium. Population would just keep growing, but incomes would stay high because you wouldn't have time to be forced all the way back to the equilibrium. But what was keeping people at the equilibrium was not the complete absence of technological advance. It was the fact that it was only improving by 1 or 2% every 100 years. And so there was ample time for population simply to do all of the adjustment it needed to do to any technological advance, right? And so it's just the slow rate of advance that actually prevents living standards from rising. And what we'll see is that when the Industrial Revolution comes, it actually comes in a background where this part of the world hasn't changed yet. There's still this upward connection between birth rates and income, and downward connection between death rates and income. And so the initial effect of the Industrial Revolution in England is to cause a population explosion. And that's actually the reason why England, before the Industrial Revolution, was a very small country on the edge of Europe. In 1450, when English population was at its low point, there were roughly 2.2 million people in England, which is less than the Sacramento area, right? And there's one actually kind of interesting reflection from that. Even by the time of Shakespeare, which is about 1600, population in England was still not more than 4 million, and only about 30% of men were literate. And so Shakespeare was drawn from a population of literate males in that society, which is less than the population of males in Sacramento. He's regarded as the finest dramatist and writer of English who ever lived, right? It's amazing that out of these tiny society, someone with this kind of amount of talent could actually emerge. And if you think about it statistically, it actually suggests that, there must be in modern America 10 or 20 or 30 people who are likely to have the level of talent of someone like Shakespeare, because we're drawing from such tiny populations in the pre-industrial world, okay? And so actually, my wife used to study philosophy, which I sometimes found tedious. And so one of the arguments I would make is, statistically, I don't care about what this philosopher says. Statistically, he's coming from a population of 50,000 people. What are the chances that he has anything significant to say, right? This is the tiniest. There's a statistical argument for why you shouldn't pay any attention to the past, because these are actually such tiny populations of people that we're drawing from. And so what actually happens in England is that in the Industrial Revolution period, with that advance of technology and this framework that we're in, within 100 years, English population had more than doubled. And England actually became the very densely populated country it is now in Europe, because it had its Industrial Revolution before we had this later demographic revolution that then reduced birth rates in all these societies and allowed further technological advances, mainly to pour into income increases. England, because it had this early advance, it ends up having this very dense population, because so much of its early technological advance went into increasing the level of population in the society. Okay? So what have we learned so far from these simple assumptions, right? We've learned astonishing things, right? I mean, every time I teach this, I think, how could it be that such a simple structure has such powerful implications, right? Some 3 almost obvious assumptions. We learn that living standards depend only on birth and death rates in the pre-industrial world. that there's no necessity for those standards to actually increase over time. And in fact, there are some arguments to make that they're likely to decrease as we move towards the Industrial Revolution. That all that technology does is increase population in this pre-industrial world, and that there's going to be no connection, consequently, between the level of technology in a society and the level of living standards. And that fact is actually very nicely illustrated by the experience of the British Navy in the South Sea Islands in the 18th century. Because by the 18th century, Britain had had the largest navy in the world. They were exploring most of the rest of the world, looking for places to refuel, to get supplies, to extend their reach. And in this process, they came across both Hawaii and Tahiti were discovered as isolated islands in the Pacific, isolated for thousands of years, discovered by the British in this period. And what was amazing was when they arrived in Tahiti in the 1760s, they found a people who were still living literally in the Stone Age. Polynesia had no metal, right? And so metal to them was this incredible material that the gods had produced, right? And it's amazing how quickly they were also the society adapted to the arrival of metal, right? But they went through several thousand years of human history in the course of one afternoon when the British ships actually turned up in these Pacific islands. Also, they had the clothing was made of bark in the South Sea Islands because you don't have they did have weaving of the bark. But they didn't have fiber that we have, in the Asia and in Europe. There's no writing system, so the entire history of these islands actually begins with the arrival of the British in terms of the written history of the islands. Warfare was through clubs and wooden spears that they fought each other with. And what was interesting, though, was that the British sailors wanted to desert the ships and live in Tahiti rather than go back to England, because living standards in the island actually seemed to be higher than those in England. The people were tall, they were healthy, they were living well, they didn't work very much. The main food supplies were breadfruit, which you just had a tree and then you harvested periodically, and pigs, which again, you just let root around and then harvested periodically. And the interesting thing was, these were the people, the sailors coming from the most technologically sophisticated society in the world, who said, we want to stay here. This is paradise, right? And so you actually see in kind of dramatic highlight there that all of that technological advance had not made the British sailors say, well, these people are living in miserable conditions. Instead, they said, these people are living very well. Right? Another thing that influenced the British sailors initially was that metal was so scarce that for a single nail, you could buy a sexual encounter. And so the British captains then on the ships had to post guards to stop the sailors from dismantling the ships that they had arrived upon, right? Because these ships are held together with nails. And so the sailors initially, their hammocks were held up with nails. Within a week, the sailors were all sleeping on the ground. And then, as I say, you had this. And what was interesting also is that we have records of the prices of metal. And it turns out that the British sailors' interest in the sex trade was so great that metal prices actually declined sharply. The island got flooded with metal very quickly. And by the time a second ship arrived a few years later, you actually could only get a sexual encounter with an axe. You needed a whole axe. And so you actually see the forces of demand and supply operating very quickly in the South Seas in this period. So that's what we learned from the Malthusian model. What else do we learn just from this simple structure? The next thing let's think about is what will happen if these curves shift. Okay? And so, for example, what would happen if the birth rate increased in a pre-industrial society? Okay? We'll see that birth rates are actually kept low, relatively low, by various limitations in different societies. In pre-industrial Western Europe, women actually married relatively late. The average age of marriage of women before 1800 is something like 25. And since women become fertile at age, even in these societies, age 16 to 18, and you're reproductively more fertile in younger years, that's actually, just that fact is avoiding almost half of all potential births. Right? The average age of last birth by women in these societies would be late 30s. And so just that social fact that women married relatively late is actually keeping this curve relatively low. Had women married earlier, there would have been this much higher birth rate schedule. So for example, if you go to China or Japan in the same period, the average woman married at age 19 to 21. Okay? And so that's actually, that feature of the difference in society would have a big effect on potential fertility. Okay? What would actually happen in a society where fertility rates increased are what we'd expect. Two things. One is the subsistence income of the society would actually decline. Everyone would live in the long run at a much lower level of living standards. And the second thing is that since the equilibrium birth rate now would be higher, life expectancy at birth, which is 1 over this birth rate, would actually then decline also. And so it's obvious in the pre-industrial world that one important thing that any society can do in order to both improve living conditions and improve life expectancy is simply to reduce the birth rate. But this is something we're also going to observe. It turns out that hunter-gatherers were as good at restricting birth rates as were people in the advanced societies around about 1800. There's no advantage that came from all of that kind of accumulation of technology in terms of this one basic feature of the society is how effective are we at restricting birth rates. And so it turns out that hunter-gatherers were just as good as these later societies. And so what that would say is the location of the birth rate schedule is not going to predict anything about increases in living standards over time, right? Because it was an issue that all societies faced, which is what is the birth rate going to be? And there's actually no significant technological advance in terms of birth control technologies before 1800. The only thing that came in was the condom, but actually in societies like Western Europe, it's actually not used very much. It's associated with prostitution, and it's not respectable for marital sex. We'll see that in Asia, birth rates actually aren't higher than in Europe because even though many more women get married and married young, somehow within marriage, the spacing of births is much further apart. And it turns out we don't know why, right? We know, and so we don't have any, it turns out one of the interesting features of history is that there's a lot of features of society that are obvious to people at the time, right? That people understand. There's a lot of implicit knowledge about society that no one writes down because it's so obvious to people and it's so clear that, well, why would anyone take detailed note of that, right? And so it turns out there are amazing things we just don't understand about earlier societies. We'll see it as we go along and talk about fertility behavior. There are things we think that someone would just say, well, why did you do that, right? Or why did people behave in that way, which just don't get written, right? There'll be the same thing for our society. In the end, no one will understand texting or something like that, or Twitter. Little generations will say, well, what were they trying to do, right? But it turns out that, as I say, there are surprising aspects of these worlds that we don't get access to because of this, as I say, this fact that people write about the extraordinary in their societies. They don't tend to want to dwell on the ordinary, okay? So that's the first thing is birth rate shifts. The next thing we can think about are, well, what about this death rate schedule? there were significant improvements in some societies in people's understanding of disease and hygiene, right? And we'll see, for example, that pre-industrial Japan was a very neat and orderly society. And people bathed frequently, and they took care to separate human waste from people. It's a very orderly society. There are other societies which are very different, and we'll come back and talk about this. Pre-industrial Western Europe seems to have been a society of filth and odor. And we actually have some descriptions there that suggest that, for example, the average person in England before 1800 never bathed. Right? It just was not part of the social repertoire. One of the sources we have for pre-industrial England is Samuel Pepys, who was a high civil servant in the British government in the 1660s. And he had a very unusual personality and kept this incredibly detailed diary. By the way, it's all available online. And in fact, there's a website you can go to. I'll send you the link, where they give a day of his diary every day, right? And it's a fascinating document because he has no censorship, right? He tells you exactly about everything, and he's fascinated by everything, and including all of his bodily functions. And he just lays it all out. The diary is actually in code because he didn't want his wife to read it, because he's having lots of extramarital affairs. And so he has to hide that from her. But in those 10 years, Samuel Pepys records his wife as having taken one bath, right? And they are living in the very upper class of London society in that period, in a very nice house in London. And he actually says of this bath, you know, my wife pretends to a new habit of cleanliness. She's gone with the maid to have a bath. We'll see how long that lasts. And the answer is apparently not very long at all. And that night, she wouldn't let him sleep with her in bed because he was still filthy. But apparently, he was back in the bed by the next night. And so it is amazing that even in the upper classes in England, it was not the case that people actually bathed systematically in the pre-industrial world. And so what we can imagine is that this curve will be shifted up or down by various social habits, also by things like population density. And here's where you actually run into a startlingly counterintuitive element of the Malthusian model. Suppose that life gets rougher. Okay, and there's lots of ways in which the death rate can increase. There's more violence in the society, more crowding, there's poor hygiene practices, there's poor public health measures. Suppose that curve shifts upwards. What actually happens now is that living standards increase in the society. Because now you're going to move to a point again where births equal deaths. But it's going to be at a point now where living standards are higher, right? Because now, because of this higher death rate, you need to give people higher incomes in order that they can produce the children that will now balance that higher death rate, okay? And so the amazing thing is that there's a reward for filth in the pre-industrial world, which is that you get to live better. And similarly, if we take a society like Japan, which we think had a very low death rate because of its orderliness, neatness, cleanliness, there's a penalty that's implied by that, which is that you live in the most straitened material circumstances because you live so cleanly, right? Now, in terms of life expectancy, what you'll actually see is that in this society, you have high material living standards but low life expectancy. In this society, you live a long time but miserably. Here, you live a short time but well. But if that curve is actually relatively flat, then it could be the case that you were just unambiguously better off because somehow you had a higher death rate in your society, right? Or that you're unambiguously worse off because somehow you end up with a lower death rate in the society. We'll come back and talk about that, but it turns out to be a kind of fascinating feature of the pre-industrial world that it's counterintuitive, the effects of health measures and in this world. Thank you. Enjoy your weekend.